Hey guys, this is going to be the last free response question. I have no idea why, but in the second free response question, when I went back and reviewed the audio, you could hear my pen just hitting the iPad. I have no idea why I decided to randomly zone in on that, and I don't know if it's going to do that for this video, but yeah, sorry about the audio. My bad. But I'm not going to go and change it, so alright. So for 8, consider the differential equation given here. A portion of the slope field of the differential equation is given below. Sketch the solution curves through the points 0, 1 and 0, 5 halves. So I guess I'll start with this one right here. I'm just going to follow these lines right here. Oh wait, that's not how it's going to go. So I think it's going to go like this right here. Something like that. And then over here, looks like it might do something like this right here. Okay. And then through the point 0, 1, this one's an easy one. Just a linear line that goes through there. Alright, cool. For 9, write an equation for the line tangent to the solution curve in part A at the point 0, 5 halves. So kind of like in the previous one, we're going to do a solution curve. We're going to write a tangent line that looks like that right there. So we have our point given here. So we know that it's going to be y minus 5 halves equal to m times by x minus 0. So what is m going to be equal to? Well, that's going to be given up here. So m will be equal to 5 halves minus 1, and then 0 plus 1 times by cosine of 0 plus pi. So that's going to be equal to 3 halves times by 1, and cosine of pi is negative 1. Yeah. So this is equal to negative 3 halves as the slope. So we have y will be equal to, y minus 5 halves equal to negative 3 halves x. Or you're okay to write it as y equals negative 3 halves x plus 5 halves. That checks out. That looks like this could be a slope of 1.5, and we obviously have a y-intercept of 5 halves. So, alright, for 10, find the particular solution to the function to the differential equation with this initial condition. Let me go ahead and copy this right here, so I don't have to, because I don't have all the, can't see up there, paste. Okay, so let's separate variables. So I'm going to separate that, and I think that's the only thing I have to separate. So 1 over y minus 1 dy will be equal to x plus 1 times by cosine of x squared plus 2x plus pi dx. So there's our separation of variables part. Now we're going to anti-differentiate. So we'll get the natural log of y minus 1 equal to, now this one might look scary, but it's actually not, guys. Because I can see, again, there's a product. If there is a product, check your differentiation rules. For AB, the only one that you need to check is U sub. And for BC, you can check U sub or parts. Or you can just see if you can get rid of the product by simplifying, but that's not going to happen. And so you can tell that the derivative of the inside, so what's the derivative of the inside of cosine? 2x plus 2, which is equivalent to 2 times by x plus 1. Now look, the derivative of the inside uses x plus 1, which is what the other piece of our product is. So that's an indication that U sub is going to be our method of integration. And so we're going to say that u is equal to x squared plus 2x plus pi. and that means du will be equal to 2x plus 2 dx, which means that dx will be equal to du over, now I'm going to factor that to be 2 times by x plus 1. And then we'll have the integral of x plus 1 times by cosine of u times by du over 2 times by x plus 1. And then you can see that the x plus 1 is going to cancel. So we have the natural log of y minus 1 is equal to 1/2 the integral of 1/2 cosine of u du. What's the antiderivative of cosine? That's going to be sine. So natural log of y minus 1 equal to 1/2 sine of u, but now I'm going to undo my substitution, sine of x squared plus 2x plus pi, and then don't forget the plus c. So if you want to confirm, if you take the derivative of sine, you're going to get cosine. Okay, that's what we got right here. Now you're going to have to do the derivative of the inside, and the derivative of the inside is going to be 2x plus 2. Well, that's not what we have, but that's why we have this 1/2 here, so that whenever I multiply by 2x plus 2, I'm also multiplying by half, which will turn that into be x plus 1. So I think we're good here. Now we're going to plug in our initial condition, so we're going to plug in our point right here. So we're going to have the natural log of 3/2, okay, equal to 1/2 sine of, if I plug in 0, that's all going to come out to just be pi plus c, and sine of pi is 0, so I'm going to get c is equal to the natural log of 3/2. So then I have the natural log of y minus 1 equal to 1/2 sine of x squared plus 2x plus pi, and then plus the natural log of 3/2. We'll do a base e. Keeping in mind, I like to do that trick, so y minus 1 will be equal to e. Ooh, that is ugly. Sine of x squared plus 2x plus pi times by e to the 3/2, which, not e to 3/2, e to the natural log of 3/2, which will then be equal to 3/2 e to the 1/2 sine of x squared plus 2x plus pi, and then plus 1 right here, so plus 1. Okay, there you go. Let's go ahead and check our key. This key isn't as good as the other ones. So part A, select a point. Okay, so the student response accurately includes the criteria below: curve through 0, 5/2, and a horizontal line through 0, 1. I think mine looks pretty good. Okay. Part B, you can get 1 point. Ooh, only 1 point for that. And an equation for the so you have to have the right slope and y-intercept. So, and then part C, ooh, they give 6 points for this one. 0 out of 6 points earned for no separation of variables. At most 4 out of 6 points if no constant of integration. The 6th point requires the expression for y. Okay, so separation of variables, check. dy, antiderivative, substitution. I'm going to assume the substitution and dx antiderivative are one and the same kind of thing. But yeah, let's make sure my response is correct. 1 plus 3/2 e to the 1/2 sine of x squared plus 2x plus pi, which is what I have. So, okay. All right, guys. I think that should cover it for this right here. Maybe over the next day, if you guys think that you want to make a suggestion on which one I pick for the test, maybe I'll listen to you guys, but maybe not. But, yeah. I'm going to make one more video for some of the multiple choice, all right?